Hello everyone, welcome to Lectures by Aparna. This is a part 1 video of linear systems. So let's see what a linear system means. So before going to linear system, we should know what a system means. So what is a system? A system is any structure of interconnected components. That is designed to perform a particular function. So system is any structure of interconnected components that is designed to perform some particular desired function. So this system, suppose this is a system, it will be having an input and corresponding to this input it will produce an output or response. So if the input is x of t, corresponding to this input once it passes through the system will produce a particular output. Say let the output be y of t. So like this they can be distinct inputs. Say x1 of t. For x1 of t it may produce an output of y1 of t. For x2 of t it may produce an output of y2 of t. So there will be distinct inputs and distinct outputs for a system. Now the relation between this output and input, this relationship will be given by a set of mathematical equations, and it is this mathematical equations that define the system. That means it is these mathematical equations that say the function of the system. So these mathematical equations will form the model of the system. So system modeling means it will be made into a particular set of mathematical equations that will explain the function that the system does. So now what is a linear system? Linear system, in the name itself there is linear. This linearity implies something related to straight lines. So say suppose the input is x of t. Suppose the input to a system is x of t and say output is y. If the relationship between this input and the output is a straight line, which is y is equal to mx, where m is the slope of this line, then we say the system is linear. That is, if the relationship between the input x and output y is given by a straight line, or y is equal to mx, which is a linear algebraic equation. Then we say the system is linear. For example, Ohm's law, systems which obey Ohm's law, say V is equal to IR. The system will be linear. Now there are many systems that use different types of mathematical equations, say differential equations, difference equations, etc. It will not be just linear algebraic equations. It will be differential equations, difference equations, etc. So we have to extend this concept of linearity to a general criterion other than the straight line form. So it is in this concept that we develop homogeneity property and superposition property. So to extend the concept of linearity to a general form, we use these two properties to define linearity. So let's see what this homogeneity property and superposition property means. Homogeneity, first let's consider homogeneity property. So suppose if I am having an input x of t and a corresponding output y of t to a system. Say this is a system and if we are giving an input x of t, we get a corresponding output of y of t. So homogeneity principle says that if I increase this x of t k times, if I give input as k x of t to the system, then the system should give the output as k times y of t. If the input I am giving is made k times of x of t, then the output should also be increased correspondingly by the scalar k. So if I am having this straight line, say I am having this straight line where y is equal to mx, this is the input x and output y. Suppose I am having an input x1 here and correspondingly I am having an output y1. If I am increasing this x1 k times, so k times x1, I will have an input here. Corresponding to this input, I will have an output, and if this output is k times of this y1, then we can say it is obeying homogeneity property. So linear systems will obey homogeneity principle. So one condition for a system to be linear is homogeneity. The next condition is superposition. It should obey superposition principle. So what does it mean, superposition principle? If suppose I am giving an input of x1 of t to the system and I am getting a response of y1 of t. Individually if I give x1 of t, I get the output y1 of t. And to the same system, if I am giving another input of x2 of t, then I will get an output, say y2 of t. Now to the same system, if I give x1 of t plus x2 of t, then if this system is obeying superposition property, then its output should be equal to y1 of t plus y2 of t, which is the combination of the outputs which we get individually when we give x1 of t and x2 of t. So this is known as superposition principle. So a linear system will be satisfying this superposition principle and homogeneity principle. So we define the linear system in terms of superposition property and homogeneity principle as a system is said to be linear if it obeys superposition property and homogeneity property. So combining these two properties, we can develop the equation. Suppose if x1 of t is the input to a system and it gives a corresponding output of y1 of t, and x2 of t is the input of a system and it gives correspondingly an output of y2 of t, then a system is said to be linear if and only if it satisfies the condition that k1 of x1 of t plus k2 of x2 of t will give a corresponding output k1 of y1 of t plus k2 of y2 of t. So this is both homogeneity principle and superposition principle combined in a combined form, where k1 and k2 are real numbers. So that is meant by a linear system. This is both homogeneity principle and superposition principle combined. k1 times if I increase x1 of t and it is superimposed with k2 times multiplied with x2 of t, then the corresponding output that the system produce should be this k1 times the response of this x1 of t plus the k2 times response of x2 of t. So we have to, if we have to check the linearity of the system, we have to check if this equation is satisfied by the system. This is a part 2 video of linear systems. So today we will discuss how to check the linearity of a system. So I am having a system with output equation y of n is equal to x of n plus 1 plus x of n minus 1. I have to check if this system is linear or not. So how will I do it? In the previous part 1 video, we discussed about a relation which is a combination of homogeneity property and superposition property, which is if an input x1, k1 x1 of t plus k2 x2 of t is given to a system, and if the output we get is in the form k1 y1 of t plus k2 y2 of t, then the output is considered to be linear. So here, since this is in discrete form, instead of x1 of t we will put x1 of n. So an input of x1 k1 x1 of n plus k2 x2 of n when given to a system, if the output we obtain is in the form of k1 y1 of n plus k2 y2 of n, then we can say the system is linear. So here we are having the equation, output equation as y of n is equal to x of n plus 1 plus x of n minus 1, which is x of n is the input to the system and the output is y of n. So what will happen to the input signal? The input signal will be left shifted by 1 unit and it will be added to the right shifted version of x of n, and output signal will be the sum of the left shifted version and the right shifted version. So this is what is happening to the input signal. So if we are having an input signal x1 of n, let the corresponding output signal be y1 of n. So we can write y1 of n is equal to x1 of n plus 1 plus x1 of n minus 1. This is a value of y1 of n. Suppose we are giving an input x2 of n, let the corresponding output be y2 of n. Then y2 of n can be written as x2 of n plus 1 plus x2 of n minus 1 for the system. Now we have to find k1 x1 of n plus k2 x2 of n. So what will happen if I give k1 x1 of n to the system? If I obtain the output as k1 y1 of n, then the homogeneity property will be satisfied. So let's see if the output is in the form k1 y1 of n. Therefore, I am giving k1 x1 of n as the input. So the output y1 of n new will be in the form, the input is k1 x1 of n, so it will be k1 x1 of n plus 1 plus k1 x1 of n minus 1, which is equal to k1 of x1 of n plus 1 plus x1 of n minus 1. So this term it is y1 of n. Therefore it is equal to k1 of y1 of n, and hence the homogeneity property is satisfied. In the same way, if we give an input k2 x2 of n, we will get the output as k2 y2 of n in the same way. Now I have to superimpose these two inputs. Therefore let's see. Now the new y of n will be equal to, our input is this whole term k1 x1 of n plus k2 x2 of n. Therefore in the input signal, first one is the left shifted version of this input. Therefore k1 x1 of n plus 1 plus k2 x2 of n plus 1. So this whole term is the left shifted version of input, plus next is the right shifted version, which will be, the input is this, therefore it will be k1 x1 of n minus 1 plus k2 x2 of n minus 1. We can rewrite the equation as y of n new is equal to k1. I am taking k1 from common from both these terms, therefore it will be k1 into x1 of n plus 1 plus x1 of n minus 1 plus, I am taking k2 common from these two terms, therefore k2 into x2 of n plus 1 plus x2 of n minus 1. So this term, this is y1 of n, and this term, this is y2 of n. Therefore this will be equal to k1 y1 of n plus k2 y2 of n, which is exactly in the form that we need. Therefore the system is linear. So this is how you will check the linearity of a system. This is a part 3 video of linear systems. So today let's consider a system whose output and input is related like this. So this is a straight line. Say this is the output y of t, this is the input x of t. This is a straight line whose equation is y of t is equal to m x of t plus c. So here m is the slope of this line and c is the intercept. This is c. So c is the intercept. This is the origin. So now this appears to be linear. So when we look at this, this is a straight line. So we'll assume it to be linear. But in actual case, this system, a system which is related like this, is not linear. So let's see why. Why this system is not considered as linear. So to be linear, it should satisfy the homogeneity property and superposition property. So let's see if the homogeneity property is satisfied. So given y of t is equal to m x of t plus c. So when an input x1 of t is given to the system, let the corresponding output be y1 of t. And when an input x2 of t is given to the system, let the output be y2 of t. So the equation for y1 of t will be equal to m, the input is x1 of t, so m x1 of t plus c, and y2 of t is equal to m x2 of t plus c. So to check homogeneity property, we have to give an input which is k times the value of x1 of t. When we give an input which is k times x1 of t, it should give an output which is k times y1 of t. If we get the output like this, then we can consider that the system is linear. So what is k y1 of t? K y1 of t is equal to k into y1 of t is m x1 of t plus c, which is equal to k m x1 of t plus k c. So this is the value of k y1 of t that we should get. Now let's put the input k x1 of t to the system and see if we are getting the output as k y1 of t. So when I am giving the input k x1 of t to the system, the output will be output new y of t is equal to m into the input is k x1 of t, k x1 of t plus c, which is equal to k m x1 of t plus c. So equation 1, equation 2. We can find that equation 1 is not equal to equation 2, which means that the homogeneity property is not satisfied, and hence this system is not linear. So even if the relation between the input, and output is a straight line, it need not be linear. It will be linear if the value of the C is equal to 0. That is, C equal to 0 means it is passing through the origin. That is, if the straight line is passing through the origin, then it will be linear. But if it is having an intercept, then the system will not be having the linearity property. If this video has helped you, please do subscribe to my channel. Thank you.